Good evening. Again, I am going to continue with the problems based on work power energy. In the previous session, we have completed up to 25 questions. Let me continue with the 26th question from the topic work power energy given in previous years of JEE Main. Look into this question. There is a statement, a truck and a car are moving with the same kinetic energy. Both the truck and the car have same kinetic energy. They are brought to rest. So, the final kinetic energy is 0 because they are brought to rest by applying brakes which provide the same retarding force. Brake force is same. Both of them come to rest in equal distances. So, he mentioned in the statement that both of them stop in the same distance, right. So, here let us see whether that statement is right or wrong. Work done against friction is equal to lost kinetic energy. So, work done against the brake force, that is Fs, is equal to lost kinetic energy, that is Ke minus finally 0. So, it is Ke, which is equal to initial Ke. In this case, the truck and the car have same initial Ke, the same brake force is applied on both of them. If these two are same for the truck and the car, they travel equal distances before they come to rest. So, both come to rest in equal distances is a correct statement. Now, look into the second statement. A car is moving east. Okay, a car is moving east, takes a turn and moves northwards. The speed remains unchanged. So, the speed of the car is same, but the direction is changed. How about the velocity? Very obviously, velocity is changing here, or velocity is changed because velocity being a vector, change in magnitude causes change in velocity, change in direction causes change in velocity, change in both also cause change in velocity. Here the magnitude of velocity, that is speed, is constant, but direction of velocity is changed. So, there is change in velocity. By definition, acceleration is rate of change of velocity. As there is some change in velocity, there is non-zero acceleration for the body. But in this statement, what is given is the acceleration of the car is 0, which is a wrong statement. So, statement 1 is correct, statement 2 is incorrect. So, option B is correct choice for that problem, right. Now, move on to this problem. Momentum of a body increases by, momentum of a body increases by 20%. Kinetic energy of the body increases by what percentage? Relation between kinetic energy and momentum is Ke is equal to P square by 2m. For the same body implies m is constant, 2 is anyway is constant factor. So, Ke proportional to P square, or K2 by K1 is equal to P2 by P1, directly proportional to P square. K2 by K1 is P2 by P1 square. While solving the problems in terms of percentages, it is easy to take the initial value as 100. So, from this expression, K2 is equal to P2 by P1 whole square into K1. P1 is 100. Momentum increases by 20. Final momentum becomes 120 whole square. Let us take initial Ke as 100. So, this is 144, 12 square by 100 into 100. So, this is 144. So, Ke increases by 44%. Ke increases by 44%. which is the right option? Option C. Okay. Now, look here. A ball is projected with kinetic energy E at an angle 60 degrees. So, this is the case of a projectile projected into air with a velocity u at an angle 60 degrees. Initial kinetic energy is given as E here. You are supposed to find kinetic energy at the highest point. At the highest point of a projectile, velocity is u cos theta. For a projectile, velocity at the highest point is u cos theta. At the highest point, kinetic energy is half m v square. V is u cos theta, u square cos square theta. But here half m u square is given as E. Theta is given as 60 degrees. E into cos square 60 is 1 by 4. So, answer is E by 4. Okay. Now, read the next problem. As per the given figure, two blocks are connected to a spring of spring constant 2 Newton per meter. Both are given a velocity v in opposite direction, maximum elongation. See, this is a spring, two blocks are connected to the ends of the spring of equal masses m. They are given velocities v each in opposite direction. Then what is the maximum possible elongation produced in the spring? So, when will the elongation be maximum? The objects are given velocities in opposite direction. So, they keep on moving till the velocity becomes 0. So, this body keeps moving till its kinetic energy becomes 0. This block moves till its kinetic energy becomes 0. So, the lost kinetic energy in both cases is half m v square plus half m v square. This lost kinetic energy will be converted into the potential energy of the stretched spring. So, here potential energy of a stretched spring is half k x square. Half m v square plus half m v square is m v square, that is equal to half k x square. Mass is given as 250 grams, convert that into kg, 0.25 v square is half, k is given as 2 Newton per meter. So, 2 and 2 gets cancelled. From this, what do we get? X square is equal to 0.25 v square. So, x is equal to root of 0.25 is 0.5 v. 0.5 is nothing but half. So, it is v by 2. That is the answer. So, here the concept behind is lost kinetic energy of both the blocks will be converted into potential energy. Then the two blocks are at their extreme position, then the extension produced in the spring is maximum. Right? Move on to the next. A boy rolling a body of mass 0.5 kg on a frictionless floor with a speed 20 meter per second. The ball gets deflected by an obstacle. After deflection, it moves with 5% of its initial Ke. What is the speed of the ball now? Look here. The relation between kinetic energy and velocity of an object is Ke is equal to half mv square. Right? As the same ball is considered, this is constant, Ke proportional to v square or v proportional to Ke. So, here what is given, what is asked? Initially, it is moving with a velocity 20 meter per second. After getting deflected, it moves with 5% of its initial Ke. As Ke is given in percentages, let us take the initial value of Ke as 100. Final value will be how much? It is 5%. So, it is 5. So, after getting deflected, what is its velocity? So, from this relation, V2 is equal to square root of K2 by K1 into V1. K2 is 5 here, K1 is 100 into V1 is 20. This is root 5, root 100 is 10 into 20. So, this is 2 root 5. V2 is equal to 2 root 5. Root 5 is 2.23 something, isn't it? 2.2 squares is 4.84. So, approximately 2.23. So, into 2, this is 4.46 roughly. So, pick out the correct option from this, very obviously 4.47. Okay. So, that is the right option for that. So, simple concept, Ke is equal to half mv square. If mass is constant, Ke proportional to v square or v proportional to root Ke. Move on to the next. Kinetic energy of a body becomes 4 times. Ke2 is 4 times its initial Ke. Then percentage change in its momentum. So, here the relation just now in the previous or another problem we have seen the relation between Ke and momentum. Ke is equal to p square by 2m. For the same body this is constant. So, p is proportional to root of Ke. So, what is asked? Percentage change in its momentum. So, P2 is equal to from this Ke2 by Ke1 under root into P1. From this expression Ke2 by Ke1 is 4. So, implies P2 is equal to root of Ke2 by Ke1 is 4 times, as the problem is asked in percentages, let us take the initial momentum as 100. So, this is root 4 is 2 here. So, this is 200. Final momentum. Initial is 100. So, increase in momentum is 200 minus 100, that is 100%. So, this is the right choice for that problem. Okay. Again, Ke is p square by 2m. Look into this model. A particle of mass move in a circular orbit under central potential field given by u as a function of r is minus c by r, where c is constant. Correct radius velocity graph. So, you have to find out the relation between radius and velocity. If potential energy is given as a variable function of distance, then force is equal to minus du by dr. du by dr. So, from that F is equal to minus d by dr of minus c by r, minus into minus becomes plus. So, F is equal to d by dr of c by r. So, this is c by d by dr of 1 by r is minus 1 by r square. This is F. But in case of a body moving in a circular orbit, force is nothing but the centripetal force, mv square by r is c by r square. So, gets cancelled, implies v square is inversely proportional to r. Of all the graphs, the graph representing x inversely proportional to y square, or here y square inversely x inversely proportional to y square. So, this is the graph, right. Okay, move on to the next problem. Look here, a block of mass 10 kg is pulled along a horizontal surface applied by a horizontal surface by a force applied at an angle 45 degrees. So, look here, this is a block placed on a horizontal surface, a force F is applied at an angle theta, right. So, the coefficient of friction mu is given as 0.25, block travels with uniform velocity, work done by the force when the displacement is 5 meters. The component of this force is F cos theta along this direction is F sin theta. Weight of the block acts in this direction, that is mg. So, in this case normal reaction is mg minus F sin theta. So, the possible friction is mu of normal reaction mg minus F sin theta that opposes the relative motion. So, friction acts in this direction. So, that block moves on the horizontal surface with uniform velocity. So, if this velocity is uniform, F cos theta is just balancing the friction. This implies the net force is equal to 0 or F cos theta is balancing friction, that is mu of mg minus F sin theta. If you take this to the other side, F of cos theta minus comes plus mu sin theta is equal to mu mg, or F is equal to mu mg by cos theta plus mu sin theta. That is the minimum horizontal force, minimum pulling force required to set the block into motion with uniform velocity. Now, in the question what is asked, what is the work done by this force? So, here force is applied in this direction, displacement is in this direction, work done is equal to F s cos theta. Now, our job is to substitute the values given in this problem. So, here work done is equal to F is mu 0.25, m is 25, g is 9.8, mu mg by cos 45 plus mu sin 45. This is F. S is 5 meters, Fs cos 45. See, this is the work done. Mu mg by cos 45 plus mu sin 45 is F. F s cos theta. But here we know cos 45 value is 1 by root 2, sin 45 value is also 1 by root 2. We can just take that as common factor and cancel. See what do we get? W is equal to, if you cancel that cos 45, it is 0.25 into 25 into 9.8 into 5 by 1 plus mu is 0.25, so 0.25. So, this is 0.25 into 25, 9.8 into 5 by 9.8 into 5 by 1.25. This gets cancelled 5 times, 5 and 5 gets cancelled, 25 9.8 is 245 joules. So, the correct answer is option C. 25 tens are 250, a little less than that. If you exactly multiply 25 with 9.8, you exactly get it as 245. Clear? See, here if you are very strong with the synopsis, minimum pulling force required to just set the block into motion or to move the block with uniform velocity is given by mu mg by cos theta plus mu sin theta, and after that work done by that force is F s cos theta. If you remember this, that problem is just calculation part is left. Okay? Now, move on to the next problem. Look here, a block is simply released from the top of the inclined plane as shown. Maximum compression in the spring when the block hits the spring. See, I am drawing the same diagram. This is an inclined plane of angle 30 degrees and this is a block of mass 5 kg. Okay, here it is mentioned that mu is equal to 0 on that inclined surface and the length of the inclined plane is given as 10 meters. Now this block moves for about a distance 2 meters on this surface which is rough, where mu is given as 0.6. There is a spring attached to a rigid surface, and this block slides down and then moves over here and pushes the spring. What is the maximum compression in the spring when the block hits the spring? So here the energy of the block is converted into energy in the spring. So energy in the spring is at its maximum compression half k x square. At the highest point, potential energy is mgh. The length of the incline is given. So from that, sin 30 is equal to h by L. H is equal to L sin 30, that is 10 into half, that is 5 meters. So mgh is its initial energy. So on reaching this point, as this is a frictionless surface, its energy is totally conserved. So that entire PE is converted into kinetic energy on reaching this point. But on this, this 2 meters length is a rough surface. So work done against frictional force is mu mgs. So on hitting the spring, the remaining energy of the block is mgh minus mu mgs, that is converted into the potential energy of the spring when it is compressed the most. So here let us substitute the values. Mass is given as 5 here, and g, let us take it as, see here, let us take g as 100, and h is 5 minus mu. Mu is given as this is given as 0.6, I think. So actually it is not clearly seen. So I think it is 0.5. I am not sure. Let us take it as 0.5. Do the calculation. If you don't get, we take it as 0.6. Okay. So mu, mass is given as 5. G, we have taken it as 10, and S is on this rough surface, it is 2. This is half. K is given as 100 x square. Okay, this becomes 50. Right? Now, look here. So we can take 50 as a common factor and cancel. 50, 50, 5 and 1 0. So 50 minus 2 into 0.5 is 1, that is equal to x square. So x square is equal to 50 minus 1, it is 49. So x is equal to 7. That is the answer. So here for the values we have taken, x is equal to 7. Here I have taken mu as 0.5. So very obviously, if you take mu as 0.6 and g as 9.8, you will be getting the answer given over there. Okay. So here with this data, the answer is 7. Okay, 7 meters. So here again I am telling you the concept. The body slides down the incline, moves on the rough surface, then strikes the spring. What is the maximum extension produced? So maximum extension is produced when the entire energy of the block is converted, is 0 and converted into potential energy. What is the energy remaining with the block just before touching the spring? That is mgh minus mu mgs, that is equal to half k x square. Everything else is given except the value of x here. We just found the value of, we just find the value of x taking the data given. Okay. So that is the problem. Go to the next problem. Look here. 3 bodies A, B, C have equal kinetic energy. Their masses are 400 grams, 400 grams, one mass is 400 grams, another is 1.2 kg, that is 1200 grams, and another is 1.6 kg, let us take it as 1600 grams. The ratio of their linear momenta. See here, they have the same kinetic energy. Kinetic energy is P square by 2m. Ke is same. So, P is proportional to root mass. You are asked to find the ratio of their momenta. So, P proportional to root m. So, P1 is to P2 is to P3 is square root of m1 root m2 is to root m3. This is root m1 is 400, root 1200, root 1600. So, this is 20 is to 1200. See, actually you can take the hundreds as common factor. So, here, so when you find the ratios, it will be root 4 is 2, root 12 is 2 root 3, root 16 is 4. Again, if you take 2 as a common factor, 1 is to root 2 is to 2. That is the answer. 1 is to root 3 is to 2, root 3 is to 2. So, this is the correct choice for that problem. So, problem is simple. Ke is P square by 2m. In the problem he mentioned all the three objects have equal kinetic energies. So, P proportional to root m. Okay. Next problem. Look here. A stationary particle breaks into two parts of masses ma, mb, which moves with velocities va, vb respectively. The ratio of kinetic energies. A stationary particle breaks into two pieces, then initial momentum is equal to the final momentum when there is no external force acting on the system, that is according to law of conservation of momentum. As the particle is initially at rest, initial momentum is 0 and it splits into two pieces of masses ma, and this mass moves with velocity va, and another piece is mb, this moves with velocity vb. So, total momentum before is equal to the total momentum of the system after splitting. This implies MAVA is equal to minus MBVB. This negative sign merely says if one piece moves in this direction, the other piece moves exactly in the opposite direction. Negative sign indicates their velocities are in opposite direction. So, the magnitudes of their momenta are same. Okay. Now, what is asked? Ratio of their kinetic energy. So, kinetic energy of the first particle is half ma va square by kinetic energy of the second particle is half mb vb square. So, half and half gets cancelled. This is, I am just separating like this, MAVA into VA. VA square is separated as VA into VA. Similarly, MBVB into VB. See here, MAVA is the momentum of the first piece, MBVB is the momentum of the second piece. As they are equal, it just gets cancelled. So, it is kinetic energy of the first piece to the second piece is VA by VB. Kinetic energy of first piece to kinetic energy of second piece. See here, but here they asked kinetic energy of second to the first. So, KB by KA will be VB by VA. So, this is the right option for that problem. Okay, simple but interesting, isn't it? Look here, a pendulum of length 1 meter has a wooden bob of mass 1 kg. It is struck by a bullet of mass 10 power minus 2 kg moving with a speed of 2 into 10 square meter per second. Bullet gets embedded in the block, the height to which it rises. The value of G is given. Look here, this is a pendulum of block mass m. This is a bullet of mass m fired with a velocity u into the block of the pendulum. On striking the block of the pendulum, the bullet is embedded in the block, and the block along with the embedded bullet, it moves aside through an angle theta, or when compared to this, it moves through a height h. So, what is the height to which the bob rises before it swings back? That means what is the maximum possible height? Look here, if you apply law of conservation of momentum, this is the bob of the pendulum at rest. This is a bullet of mass m moving with a velocity u. On hitting the bob, the bullet is embedded in the block, they move with a common velocity v. Then mu is equal to, this is m, total mass becomes m plus m into v, from which v is equal to m by m plus m into u. So, v is equal to, mass of the bullet is given as 10 power minus 2 kg, 10 power minus 2. Mass of the block is 1 kg, 1 plus 10 power minus 2, this can be neglected. So, this is 1 into velocity of the bullet is given as 2 into 10 square. 10 square and 10 power minus 2 goes off, v is equal to 2 meter per second. So, with that velocity, to what maximum height it rises? From your law of conservation of momentum, this is the kinetic, the system can go to a maximum height till its entire kinetic energy is lost. Half mv square is equal to mgh. Half mv square is mg into h, from which h is equal to v square by 2g, right. So, maximum height reached is v square is 2 into 2 by 2 into g. So, this is 2 by 10, that is 0.2 meters. This is the correct option for that problem. Look here, is that okay? Now, next problem, look here, a bullet of mass 200 grams with initial kinetic energy 90 joules. Mass of the bullet is given as 200 grams, initial kinetic energy is 90 joules. Shot inside a long swimming pool as shown in the figure, the kinetic energy reduces to 40 joules within 1 second. The minimum length of the pool before the bullet has to travel so that it completely it comes to rest. I think the diagram is in the next page. Let us see. This is the diagram with the options like this. Okay. Now, going back, see here, this is the pool in which the bullet is fired and its energy reduces from 90 to 40 in 1 second. What is the total distance travelled by the bullet before it stops? Okay. So, here total distance travelled before it stops can be found from the relation work done against friction is equal to lost kinetic energy. Lost kinetic energy is, as finally it is coming to stop, lost kinetic energy is equal to its initial Ke. Okay. So, here you are supposed to find S here. So, initial Ke is given, but F is not given. That is force of resistance offered to the bullet by the water. So, here to find the force of resistance offered, let us try to find out this data. So, here if you convert this mass into kg, it is 2 kg. So, here F into T is equal to lost momentum, isn't it? So, final F into T is initial momentum minus final momentum. So, we try to find out the retarding force from this expression or force of resistance from this expression. Here T is given as 1 second, but its energy is reduced from 90 to 40. So, you have to find out the corresponding momentum. So, Ke is equal to P square by 2m implies P is equal to square root of 2m Ke. So, P1 is equal to square root of 2, m is 0.2 and Ke is 90. So, this is 2 3s are 6. So, initial momentum is 6 Newton second. Similarly, final momentum is square root of 2 m, final Ke is 40. So, this 0 and this decimal gets cancelled, 2 it is 16 under root, it is 4 Newton second. This is the final momentum. Substituting those values in this expression, F into time is 1 second, that is P1 minus P2. So, F is equal to 6 minus 4, 2 Newton. Why did we find this F? Because you are asked to find out the distance travelled by the bullet before it completely stops. Okay. So, substituting this here, F is equal to 2, S, and lost kinetic energy is initial minus 0. From this, S is equal to 45 meters. So, the distance travelled by the bullet in water before it stops is 45 meters. So, it completely comes to rest. The minimum length required is 45 meters. Look at the options. See, this is the correct option for that problem. Okay. So, I will stop here for today. In the next session, I am going to continue with some more problems. Thank you and bye-bye.